Good morning. I have a few questions I want to go over for this week. I got several questions that have been sent in. The first question comes from the review section. This is review question number 53 in the book, and it comes number 14 on the intermediate algebra review homework. Okay, this is shortcut number, looks like number 4 or 5. Okay, Hubert, what the heck are you talking about? Well, if you watch my videos, I go through the shortcuts. Now, the shortcuts is something that you should have learned in Math 101 and 102. The first 3 shortcuts you probably learned at the end of 101 or Algebra 1, and then the 4th and 5th shortcuts you may have learned, or all of them you may have learned in Math 102. But the shortcuts are, and if you go to my videos, you'll see it. A plus B, quantity squared, is equal to A squared plus 2AB plus B squared. That's shortcut number 1. Shortcut number 2, A minus B, quantity squared, is equal to A squared minus 2AB plus B squared. And A squared minus B squared is equal to A plus B times A minus B. And A cubed plus B cubed is equal to A plus B times A squared minus AB, plus AB plus C squared. Sorry about that, that's my phone. A cubed, does that in class too, minus B cubed is equal to A minus B times A squared. A plus B, A squared minus AB plus B squared.
Priority 1 message coming in on secure.
So those are your 5 shortcuts, and they go in that order, 1, 2, 3, 4, 5. Now, if you don't know them, then you're at a loss because you should have been taught those before you get to Math 110. Let me make sure my son's not in trouble at school. And if you don't learn them, you need to learn them. If you haven't learned them, then you need to learn them. Okay? So let me turn this thing on. He's not in trouble. So as long as he's not in trouble. You got to know your perfect cubes too. Now, how do you know this is shortcut number 5? Well, 1, it is not shortcut number 1, 2, or 3. Why? Because it's a cube. A little 3 there, this little 3 right here tells you it's a cube. So it's either shortcut number 4 or number 5. The minus tells you it's shortcut number 5. So I'm going to rewrite the problem. 125 x cubed minus 1. And then I'm going to put shortcut number 5 under it. A cubed minus B cubed is equal to A plus B times A squared minus AB plus B squared. Now you just find what A and B is. Well, here's A cubed. A cubed is equal to 125 x cubed. A, you got to take the cube root of everything. So A is equal to 5x. B cubed is equal to 1. Take the cube root of everything. B is equal to 1. Now you just plug and chug into the right-hand side. I'm going to go up here and do it. So parentheses, put a plus there. Parentheses squared minus parentheses times parentheses plus parentheses squared. I just rewrote this, and wherever there was an A or B, I just put a set of parentheses. Okay? Now what's my A? 5x. So you put a 5x here, you put a 5x here, and you put a 5x here. And now you put a 1 here, a 1 here, and a 1 here. And now you just simplify. 5x plus 1 times 25 x squared. Don't forget the 5 is squared also, along with x squared. That's where students make the biggest mistake. Minus 5x plus 1. And that is how you factor this polynomial into two polynomials. That's how you do it. Now, if you don't know how to use these shortcuts, you need to go back over into my videos, and you need to, and if you don't see it in the 110 videos, I think I have some 102 videos way back a couple of years ago. You might want to go to the 102 videos. If not, I'll make another one. Send me a request or send me some more. Just send me the questions, and that way I'll just keep going over it until everybody gets it. Okay? So we click on A and see if Hubert knows what he's doing. Let's see if Hubert knows what he's doing. Oh, I got to type in all that stuff. Okay, let me type it in. Parentheses, 5x plus 1, close parentheses, open parentheses, 25x squared minus 5x plus 1. I think it's plus 1, isn't it? Yeah. Plus 1 and close parentheses. Oh, I got the plus and the minus backwards. I'm sorry. I must have did that on the shortcut. Should be a minus right here. Sorry. That's a minus. And this is a plus. I think the phone going off messed me up. Let's see. That's a plus. It's backwards. Let me hold on down here. On the shortcut, this is supposed to be a minus right here. And this is supposed to be a plus. Backwards. Okay, so that's a minus. And this is a plus. Okay? And this is a plus, and this should be a minus. There we go. So, what do you do first? First thing you do is figure out which shortcut it is. The second thing you do is you put the shortcut under it. Then you find out what A and B is. And then after you find out what A and B is, you plug and chug and simplify. Okay? So hopefully that'll help you. Let's go to the next problem. Next problem is, hold on just a minute.
No, it's okay. Do you know where Mr. Woods is? They
say where anybody is this morning.
Okay.
That's down at the front. That's down at the front desk.
Okay.
Okay. Yes, ma'am. Sorry about that. I think they just heard me and had to ask a question. All right. Now, that's that question. That's a review question. Now, I answered this question last week. I'm going to answer this question this week and then go to 2.3 and 2.5. This is 2.1, 65 in the book, number 19 online. 65 in the book in 2.1 and number 19 online. Okay, what does it say do? Determine whether the graph of the given function is symmetric, blah, 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 blah. Use your calculator, standard window to support. Okay, this is a calculator drill, but you know it's a quartic function. It's to the 4th power. Now, this goes back to the video where I gave you the family of graphs. It's where I told students in the video to take a piece of paper and draw it into 8 sections or something like that. And this section, that's x to the 1st power. I'm sorry, that's x to the 2nd power. Here's x to the 1st power. I'm not drawing right, I'm sorry. There's a straight line is x to the 1st power. This is x cubed. And x to the 4th looks like a parabola, but it's flatter on the bottom. Like that, that's x to the 4th. You just have to look in the video. It's called family of graphs or parent graphs. And there's about 8 or 9 that I put on there, square root function, but you have to look at it. Now, this one is going to follow some kind of a quartic function, because it's got a leading exponent of 4, okay? The leading term is x to the 4th power, so 4th degree polynomial. You need to know that because that's just the way it is. It bends 3 times. So it's probably looking like a saddle. It's probably looking something like this. You take this one right here, and you think, okay, it bends 3 times because this right here, 4 minus 1 is equal to 3. So it bends 3 times. So it's probably going to look like this, but it's going to have a little bend in it. So chances are it's going to look something like that. Okay, it bends like 1, 2, 3 times. 1, 2, 3 times. It bends 3 times. That's what's called a saddle. All right. It looks like that, but the best thing to do on this problem is to just do it on your calculator. All right. So, and some of these in 2.1 is nothing but calculator drills, and in this case, this is a calculator drill question. So I'm going to take my handy-dandy calculator, and I'm going to punch in. For those of you that need to know how to use the calculator, I got to move it first. I hope I can move it to where I can. Sometimes this calculator doesn't cooperate with me. X to the 4th minus 2x squared. It's not. Okay, so hit the y equals, and then type in, let me get rid of this writing, x to the 4th, so hit that x key right here, x, caret symbol, to the 4th, arrow over, minus 2x squared, caret 2, and then graph. Now, when you do this, you're going to, there's the saddle. I told you it was going to be a saddle and it was going to turn in 3 places. So make sure that you see it. Now, is it symmetrical? Well, if I was you, I would pull that thing up. It looks symmetrical from far away, but there's a thing called hidden behavior. You need to be aware of hidden behavior. Now, what I'm going to do is I'm going to hit zoom and I'm going to go down to fit and hit enter. There we go. Now we're talking. And look at there. All right. Now you can zoom out. And these are just little drills, little things that you can do. Put the center down at the bottom, like there, and hit enter. And let's say that's not good enough. Well, let's go to zoom box. And I'm going to put the left-hand corner right above the x-axis, right there. And I'm going to hit enter. And I'm going to go right below the x-axis. And I'm going to go down a little bit more right in there. And let's see what this does. Hit enter. Still don't see too much. I'm going to blow it up some more. So I go here, zoom box. And I'm going to put the left hand right in there. And I'm going to hit enter. Doesn't look like to me it's doing too much. Let's look at the window. Hit the window key. And x-min -3 to +4, that's okay. But the y-min is a little bit crazy. You're going from -500 to 304. I don't know about that. I'm going to go from -100 to +100. Let's see what happens when we do that. And hit graph. You're still getting the same type graph. So I think you're going to be symmetrical around the y-axis. I don't know what your choices are. It looks like symmetric with respect to the y-axis. And you hit finish. Nice work. We feel good about ourselves. All right. Again, this is a calculator drill. If I was to give you this on a test, you would do it solely on the calculator. So learn how to use that calculator. If not, send more questions, and I'll go over it again. 2.3, let's see, that's number 19, and that's number 19. So we're getting two questions from the same person, different person, same question. So let's see, it must be confusing. 2.3, number 19, number 4, online, number 4. Okay. This is a transformation. This is, again, where you need to use that parent graph chart that I do in the video. Okay? We know this is an x squared function. All right? So the x squared function is a basic function that looks like this. And this is in your parent graph. So that's the x squared function. All right? If x has a number attached to it in the front, then we know that makes it skinny or wider. Okay? And I go through this in the videos. So if I have a y is equal to 1/4 x squared, this is called a, and I go through this in the video, and that a right there, if it is between 0 and 1, meaning a fraction, a regular proper fraction, if it's a proper fraction, that means it's going to be wide. Okay? So I can already tell, I'm going to do this in red, that this function right here, this 1/4 x squared, is going to be wider than my black function, okay, because of this 1/4. Okay? If there is something to the right of the x and still in the square, if it's in here like -2 and then they have a quantity squared, that's called the horizontal shift. I go through this in the videos also. But there is no x, there is nothing there to the right of the x, and students are going to say, no, Hubert, there's a 3 out there, but that's not attached to the x, okay? If you'll look, see here the parentheses and then the square, and then you have a 3. In other words, there's two types of this problem. There's this, y is equal to 4x quantity squared minus 3, and then there's y is equal to 4x minus 3 to the second power, like that. See, the 3 is attached to the x here, and it's inside the square. Here, the square is finished with the x here, and then you got the -3. This is called a horizontal shift. This is called a vertical shift. And I go through that in the video. Okay? So, I know here, I've got a vertical shift of 3 down. So, I'm going to move, I don't know if it'll let me do this, but I'm going to, yep, just ignore that over there. Okay, so the 1/4 x squared minus 3, I'm going to move it down 3. 1, 2, 3. And there's that one. And then I'll do the blue. I know that the 4, if A is 4, if A is greater than 1, which in this case is 4, A is equal to 4, in this case, it's going to be skinny. It's going to be skinnier than the black graph, parent graph. So it's going to look something like this. And it has also a vertical shift of -3. So I'm going to take that blue one and I'm going to pull it down here to -3 like that. So your finished graph over here is going to look like this. Oops, sorry. It's going to look like this. That's what it's going to look like. Now, all of this is on the video. I also talk about compression. What happened to the black graph with the red? Well, I stretched it along the x-axis and I compressed it along the y-axis, and that made it flatten out. Think of it like a balloon, and you put it between your fingers or your hands and you push on it. Okay? If you push on it from both directions, it's going to squish out to the right and to the left. Versus if you pull on it at one end and pull it, it's going to stretch it. So the red, so look at the black graph right here and look at the red. Besides the vertical shift, I squished it like this on the y-axis, and I pulled it like this along the x-axis. So I stretched it along the x-axis, and I compressed it along the y-axis. Both of them do the same thing. It makes it a squatty type graph. Well, what about the blue? What's the difference between the black and the blue graph? Well, I compressed it along the x-axis, and I stretched it along the y-axis. So you need to be able to, and that all depends on the a, which is in front of the x squared. And again, I cover this in the videos on parent graphs. Okay? So what I would do is go to the videos of 2.3, or it may say parent graphs, or it may say vertical and horizontal shifts, something like that, and brush up on that. Okay? Now, when you put it in the video, when you put it in the graph, you just have to, let's see, I don't know if it'll let me. No, it's not going to let me because somebody's already done it, I think. Hold on. Yeah, it won't let me. But you have to play with the graph, and you have to think about the compression. You have to think about where is it symmetric, and you have to put all that stuff in to get it to graph. If you need me to show you how to use the graph, then you need to send me a question that you don't have on the graph, okay? That you don't have something graphed. All right, but it looks like to me that they've got x squared minus 3. That black one should be down there too, I'm sorry. The x squared minus 3, let me move the black one. It's probably going to move everything, so I might not move it. Yeah. Yeah, it's not going to move it, so I'm going to leave it right there. Okay? That black one needs to be down here too, so that looks right. Okay? Again, send me questions if you need to, and but I do, and I'm not fussing, and I don't know if you've looked at the videos or not, but make sure you do go through the videos, because I do cover a lot of this material in the videos, and every once in a while I get students that think they can take an online class and not watch the videos, and it gets a little bit cumbersome when people send you the questions and you cover it in the videos. So make sure you visit the videos before you try the homework. I'd appreciate it. And let's go to the next question. And keep sending them. You keep sending them, and I'll keep doing them. But make sure you do go to the videos, because you may not have to send them if you go to the videos. I'll shut up. Okay. Next one, this is 2.3, this one right here. Oh, they're the same. 2.5. 2.5, number 55 in the book, number 21 online. This is a piecewise function. I don't do a lot of piecewise functions on the test, but let's see what it says. It says the graph of y is equal to f of x gives the speed limit y, speed limit's right here, speed limit's there, along a rural highway after traveling X miles. So after traveling so many miles, you drop down to this speed, and then after traveling this speed, you drop down to this speed, and then at this right here, you speed up. Okay, that's what it's saying. What are the maximum and minimum speeds along this stretch of highway? Well, the minimum is going to be the lowest one, which is this one. And I don't know. It says the X scale is 40, but the Y scale is 10. So this is 10 miles an hour, 20 miles an hour, 30 miles an hour. It looks like 35. That's 35 right there. And then this is 40, and then this is 50. So I would say probably 35 right there. And you can blow it up right here. So you can blow it up, and then you have to take your handy dandy straight edge. And here's my straight edge. I'm going to put a dot right, I'm going to start from right here. If I can get it in the center. And I think that's level. And you see it's between these two dots. Well, the Y scale says 10. So that means 10, 20, 30, and half of 10 is 5, so that'd be 35. 40, and then 50. So the min is 35, and the max is 50. Let's see what the other question says. if I can get out of here. The other question says, estimate the miles of highway with the speed limit of 50 miles per hour. How many miles did you travel 50 miles per hour? So let's take our handy dandy straight edge and let's drop a line from the end of this line down. Ooh, it hits that little mark right there. That's good. And then from here, that's 50 to here. And that's good because it falls on the little hash marks. So this is one hash mark and this is one hash mark. But again, let's go back to we know it's one hash mark and one hash mark. All right? So the X scale, one tick mark is 4 miles. So 4 miles here and 4 miles here is 8 miles. So you would type in 8 and check answer. And you feel good about yourself. So you don't have to put smokestacks on your truck. All right, question. Oh, evaluate f of 4. F of 4 means that x is equal to 4. All right? F of 4 means that you're plugging in x is equal to 4. So x is equal to 4 is right here, and there is a dot right there, and that is at 10, 20, 30, 40. So that would be 40. F of 4 is 40. And you hit check answer, and you feel good about yourself. F of 8. This is 4, this is 8. 8 is 50. So you would type in 50. Okay, what 3? I don't like 15-part questions. At what 3x values is the graph discontinuous? Discontinuous means don't join. 1, 2, 3. So at 4, at 8, and what's in the middle of 4 and 8? 6. So I would say 4, 6, and 8. So this problem is basically how to read a graph. That's how to read a graph, and that's how you do it. Is it a test question? I doubt it. Does the previous problems test questions? Probably. But this one's not. Because I don't do a lot of piecewise functions. Okay? Let's look at the next question, or is that it? I think that's it. Okay. So that's it for the Math 110 Virtual Office Hour 2. I do want to say, make sure you, 1, watch the videos. 2, when you're watching the videos, write notes and follow along with the book. 3, make sure you do the attendance quiz by midnight every Sunday night. Now, the first attendance quiz is done past. All right, it passed, and everybody was supposed to do it that first week. The second one is going to shut off midnight Sunday night, so make sure you get the second one done. All right. I think that's pretty much it. And make sure you get finished with your homework before the designated time. Make sure you send in questions to me so I can do these weekly office hours. And between the videos that I've already gave to you on YouTube, as well as these virtual office hours, everybody should be able to get their questions answered. So let me know if I can help, and I'll be glad to. Just send the questions in, and I'll be glad to do them. Other than that, hope y'all have a good weekend.